Okay, so once you got that installed in your current environment, in your Python 3 environment, this command should work. And so what we're going to do is we're going to use this pandas command. We saw these when we were reading and writing files. We had just a little bit of experience with these. We're going to do pd. So again, we imported NumPy as np. Here we import pandas as pd, and we're importing matplotlib.pyplot as plt. So there's these three different kind of shorthands that we're using. So pd, or pandas read CSV, we're going to pass the path of that file we just imported. So this file is living in data, which is up one from lessons where we are now, in data, and then in data it's called scripts peer 2015-1110. We're going to say no index column, and the header row is going to be row 0. So when we import that, and then we have this function called head, it'll give us just the first 5 rows of that data. So we can see that it used the first row of that data as CSV. Sorry, the first row of that data as the headers from that CSV file, and it's giving us indexing just numerically. If we do the same command, we're going to save this as a different data frame called data 2. This one was data 1. These are both pandas data frames. If we do the same thing with, do the same kind of import, but instead of saying index column none, we say index column equals 0. This is going to use column 0 as our index column, and we're still going to use header, or as row 0 as our header. So we execute that, and then we look at that, and we can see now that the indexes are what we call these. This first row, it's in black and in bold here. The indexes are now the dates, and the column headers are still that first row of data. So so in pandas terminology, the column headers are called columns, and the row labels are called indexes. So if we want to get some basic information about this data frame, we can use this function called describe. It's just a handy function. There's a ton of different functions that we can do with pandas data frames, but this will give us some basic statistical output about that data frame: the count, the mean, standard deviation, percentiles, etc. So we talked about indexing in NumPy. In pandas it's very similar, but there's additional options. So if you want to use the numerical style indexing, you can use this iloc method and specify the position. So this will give us the first row of data, basically, here. Or if we want just the temperature column, we can specify. We don't need to specify any iloc. We just specify the column header in brackets. We'll spend a lot more time with this. So this is just very first look at pandas. If there's no index column, so we no longer have a column named temp degree C or temp parentheses C, we can use sorry, we still have those same headers, but we no longer have indexes that are the dates. So we can use these positional indexing. So in this case, this is a little interesting. So iloc is index-based, getting those rows out using the index. So this is row 0. With but it also turns out that row 0 positionally also has the label row 0. So this label is the name of that row is also the position of the row. So if we want to use that label based, we can do the same thing here. So this would be like doing data 2 loc. I think this will work. Yeah. So it's the same. It's all three of these formats are giving us the same data, just in different ways. And we can see that the date column, when the date is stored as another column of data, has this data type object, but it's also possible to convert that to a datetime object, as we'll see in a second. Also, when the column has a header that is a single word that has no spaces or special characters, we can omit the quotes and the brackets and just write the name of the data frame dot the name of the column, and then here we're just doing head to get the first few rows. Similarly, if we wanted to use positional indexing, we can use the iloc again, all rows, column 0. This is giving us the same information using the position instead of the name. So there's, well, again, we're going to spend a lot more time on this. You can see there's some similarities to NumPy, but there's some important differences too. You can also you can convert that date column to a date time object. So this is taking this information in this column. So this is data 1, iloc, all rows, column 0. So same information here. We're converting that using this pandas function to date time to a time, and now we can see that those dates have been converted to sort of a more standard date time format. And instead of having it type object, which is a string, it now has this data type date time. And that thing that we just created is has data type. In fact, we can do, just like with NumPy, we have, interesting. Oh, okay, that was right. It's just, yeah, this is just the shorthand version of the data type. So these are kind of the same thing. So this is a series. A series is like an array in pandas. So the analog for a one-dimensional array in pandas is called a series in pandas. For a two-dimensional NumPy array is a data frame. But the difference is that a data frame is composed of many series, and each of those series is like a column in the data frame, and each of those series can have a different data type. So that's where pandas data frame has more flexibility than a NumPy array. So NumPy array, that two-dimensional table has to all have the same type of data, all floats or all integers. But with NumPy, you can have floats in one row, one column, integers in another column, strings in another column, date time objects in another column, etc. The only restriction is that each column has to have its own data type, and each of those columns is a series.
So can pandas be multi-dimensional?
Yes, you can have at least 3 dimensions. So that would be called a panel. A panel is, so you can think of one dimension is a series. It's like a list or an array. 2 dimensions is a data frame. It's like a two-dimensional table. And then a panel would be, you have these data frames like stacked on top of each other. So let's say for every point in time, you have a series of stations and observations, right? And then, so if you were doing a time series, you could have one data frame for each time point, and then when those data frames are each with their own time are stacked together, that becomes a panel. So that's actually where the name pandas comes from, panel data. So finally, I just want to show you a quick example with Matplotlib, so how we can take this data and make a nice plot with it. So we're going to do a very basic plot where we're going to create a figure. We're going to plot chlorophyll versus time. We're going to label those axes, and then we're going to save that as a PDF. So this is now showing us time as our x-axis, chlorophyll as our y-axis, and we have this nice plot. We could also plot each of those independently using a loop. So first we're going to rename the columns to make it simpler. So we're going to change each one of these column names to just a single word. This will make our life easier when we do the loop. So now we can have a look at that data just to see what we changed. We can see those columns were changed, and we can check that using this columns attribute that'll list out the columns, and it has this type index. And now we're going to say for each column in that list of columns, as long as the column is not the date, create a figure, plot that column versus time, label them, and then create a new figure with where we insert the name of the column as a string insertion here. So this is why we changed all the names from where they had parentheses and slashes and things. That makes it messy to just use that as the name of a file. So we're simplifying those names to make them easier to handle. So this is going to loop through and make 4 plots. We have chlorophyll that we just did, but now we also have pressure, salinity, and temperature, all in one single command. Alternatively, if we wanted to put all these on the same axes, we could do, again, we're going to start with this where we have the columns as they were before. We're going to convert the index here to date time object. This will give us better treatment of that x-axis, so it understands its time. So now we've converted this index column from, which is just an object type or a string, to a date time type, and now we're going to create a figure with these 4 all on the same axis. Now these are in different units, so they appear quite flat. So there's ways to plot like 2 axes on the left and right. We'll see how to do that later. But this just shows you how you would put, just using this basic pandas function plot, you can plot the data as a single graph. So that's pandas. As I said, it's not actually about pandas. It's about panel data, but it's kind of a fun name. You can think about pandas when you think about it. And we're going to spend the next 3 weeks or so, really the rest of the course, we're going to be using pandas. This is what everyone uses in data science, and so, but everything we've done to this point is kind of building up to this, including the NumPy stuff we talked about, understanding all the different data types, understanding loops and functions and Boolean values and the operations you do with those, regular expressions, command line stuff as well. Like everything we've done is going to build up into what we're going to do next. So that is it for today, unless there's any other questions. All right, I'll see you guys next week.